In this case, we need to talk about the object class. What is object class? Object class is the parents for the whole classes in Python. Okay? Which means that if we create any class sample, just like this one, pass. If I run this code, and so this code gives us nothing on the terminal page, but the sample class is also another parent in here. Either we can write it or not. This is the identical with the upper one. We have the object class just like this one. Okay? And so if I run this code, and then we will have to what? To this one. And so this is the identical with the upper definition. Okay? Because in the Python programming language, we have this property. Okay? So this object is the basis for every class definition in here. And so we can say that the every class we write in Python is the derived class. But the basis of every class is related to the what? The object class. How can I prove it? Firstly, the sample dot is called right now, but sample have the any objects in here or any function, but we have the many parameters in here. For example, the MRO or basis or call or dir or egg or get attribute or hash or init or something like that. See the name. Which means that if we have these properties or the methods in here, and so these properties or the attributes or the methods should be defined previously, which is defined in the what? In the object. Okay? Do you understand the properties of the object? Objects has these properties already. And so if we create a sample class just like this one, and so this sample is inherited by the what? The object, or is derived from the object class. And object class has this str function, size of function, repar, reduce x, or the new, or the init. Right? Do you understand the feature of this behavior in here? We have already written these functions in the what? In the objects. And so we can easily use these properties or the functions. For example, the init function, either we can write or not, the object define it. Okay? Any question? If there's no question, and so we can search the parameters or the features of the object class. Okay? First of all, the MRO body or function. Okay? It returns the hierarchical behavior. Okay? Class A, pass. And class B, derived from A, and pass, and class C derived from B. Okay, pass. And so the print C dot MORO function can be called in here, or the variable of this property can be called in here with the return values of the what? This one. And so this is the attributes. Okay, MRO attributes. And so if I run this code, we will have what? The class main C. And so this class main C has a parent, class main.b and class main.a. See? And so class object possesses everything related to these bodies. Which means that this is the name of the class. And this is the basis of this class. But the B is derived from the main of A. And so this A also derived from the what? The object class in here. This features returns to the what? The which class depends or derived from the which classes. Okay? Do you have any question about that? If there's no question, and so what about this properties? Class A, pass. Class B, but derived from A, pass. Class C, right now A and B can be used in here with the pass. See, this is the double inheritance, just like your mother and the father. Okay, and so C is a child, but the A is your mother, B is your father. Okay, this is the double inheritance. But what is the output of this code? This attribute returns to the basis of these classes. And so if this is the case, and so if I run this code, see, if we don't have any feature to this one, and so MRO cannot be called in here because I cannot create a constant method resolution. Order MRO for bases A and B. See that? This cannot return the values of this one because the C is already derived from the B and already derived from the A, but the B possesses this feature, and so this is the directly related to the class, and so we can give the error in here just like this one. Okay, do you understand the error arising from this condition? We have the double inheritance in here, and so the MRO cannot resolve these features in here. Okay, so how we can utilize these features? The multiple inheritance. How we can derive it? See that the class A can be built with the def foo self print foo. Okay, class B def bar self and print bar. Okay, and so A and B are separate classes, and so the class C A B can be defined just like this one, and so def tar self print tar can be called in here. Okay, and so C can be built with the C constructor, and C foo can be called in here because the C possesses the A functional attributes, and also C bar can be called because the C also possesses the functions of the B, and C tar can also be called in here just like this one. Okay, but the print C dot MRO is written in here just now. There's no error in here, but why? In the previous case we have the error, but right now we don't have any error. Why? Can anyone say that? Previous code order is not is the case. In this case, in the previous example, C derived from the B, but the B is derived from the A. Okay, and so but the C is derived A and B, but the B is has already properties of the A, and so the resolution cannot be provided with this one because just using the A is enough to possess the properties of the A within the C. But in this case, A and B are separate function. A and B are separate classes, and so we don't have any error in here. Okay, You get it? And so we can resolve these conditions in here. C mainly depends on the what, the A and B, and also object possessed everything is given in here, just like this one. Okay? So we need to continue with what? With this one. X10, X11. Okay. So class A def init function can be defined in here, and so we can print the what? The A init called just like this one. And but we have the format and type of self. Just remember the type function in here. Type returns the type of the variable, and so self has possessed what? The variable of the A. Okay, and so self x can be assigned with what? With the 10. And after that we can create the this A in here, the self, and so the print A in this function returns to the what? To the values of the self x. Okay, so the class B def init is given in here, and also we need to write the print just like this one. We can copy all of these things in here, the print, but this is the B, and so this is type of the B, but the super must be called with what? The B and self. Okay, the init function should be called, and self x is 20. Okay, what about this one? Def disp B self, the print B disp is given by with what? The format of self.x. Okay, just see that this is the 10, this is the 20. Okay, so what happened if I run this code? If you create the B variable with the type of the B, what is the output of this code? Just say it. Can anyone say that? Yes. So B init code. What is the type of the self in here? Type of the self main.b. Okay. And so, but what is the type of the A init code in here? Just see that class main.b. See the picture? A init code is returned with the what? The main.b. Normally, this must be equals to what? The main.a, right? Because of this self should be assigned in here. But in the inheritance case, this self is created with what? The main.b. Okay? Because we possessed what? The B, super self should be given in here, and so this self is created, and also this self is created, and so the B self is passed into the what? Into the A, and so the type of the this one is the main B. Okay, main B, but the another one is also main B in here. But what about this one? This B. What is the output of right now of this code? We have two self x in here. Yes, 20. See? But what about this one? What is the output of the display? if this self is passed into the A, and so self x is 20, okay? And after that, x is equals to the 10, but this self x is different from the another one. See, this A is also 20, but why is that? Why is that? Can anyone say that? The main reason is that in the super B, self is created in here, and so this self is passed into the what? Into the A, okay? And so main dot B is created in here, and also self X is created. But in this case, if the B is called to this A, and so the self of B is passed into these arguments, okay? And so this self X cannot be seen by the B right now, okay? Because the super B self is passed into the arguments of the init function, and we can call it, and so this self contains already self.x is equals to the 20, okay? And so this is equals to the 20, and this is also equals to the 20, okay? In order to understand easily this process, we can drive the another examples in here, just like this one. Class A, def self print A dot foo, okay? And also class B, A def self print B foo, okay? Because the super B self is called in here, this super B in it calls this function, yara. That's it. So we have two foo function with the same name. A created A, and so A foo is written in here. And so what is the output of this code, yara? Yes, A foo. And so the B, and B foo is code. What is the output of this code right now? We have two foo in here. What is the output of the B dot foo? In this case, this B is overwrites these terms. Overwrites these terms. Super dot foo. Right now, what is the output of this code? A foo, but so we also just see that this is the first case, but in the second case, super function dot foo calls to A foo, but in the second place, B foo is written in here. And so if we want to call any base function or inherited function, we need to utilize what a super function in here, okay? Okay? And so we can create a more complex example, but simple example, in order to understand the full feature of the multiple inheritance in here. So x13 and class A can be defined with the def foo self print a.foo, okay, and class B right from A def foo self print b.foo, okay. So the B is created with what the B. What about this one? A is a general name of the class of this one, foo B. What happened if I run this code? What happened? See, in this case, the a foo is printing because the a possesses this function, but the b is derived from the what? The a, and so we can pass the arguments of the b into the what? Into the a dot foo, okay? Because the self of a can be passed with child class, okay? B is derived from the A, and so we can use the properties of the what? The self instead of this one, because in the previous case, just remember that this self is already passed to the what? To the base class, and so we can use it. But super B and B dot foo. What's the output of this code right now? Just tell me, Yara. In this case, we can call the what? The a foo, because in this case, the super indicates the what? The base class, right? Just see that. The super of B is A, and so we can pass the arguments of the B because the B is right from the A, and so we can call the foo function, which is given in the what? The class of A, okay? This is the case, guys. Okay? Any question? In this case, B dot foo B, but the B possessed what? The foo of B already in here. See, B foo is called in here, but the super goes to base class or inherited class, okay? Okay. So week 10 q.py can be written in here, and so in this case we need to talk about the overload and override concept. Overload and override concept. This is our main topic for the section 2, okay? So first of all, we need to give some explanation about that. In Python there is no overload mechanism, since we can define any variable at the downside of this code. For example, if we create the a is equals to the 1, and so we can write what? A def a function, because everything is an address in the Python. It has a dynamic structure, okay? And so we can create the what? The variables with the same name, and after that we can derive what? The class of name, and after that we can define the what? The function name, okay? And so the new variable and the function can easily be assigned to the another one in runtime application, okay? Also, the function or variable names, okay? So How we can explain the overload and the override concept based on these informations? Next one, the foo. We can print the foo. Okay, so the print foo. See, if we write the foo, and so this is the what the function foo at blah 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 address. Okay, and also we can print the what the type of the foo, just like this one. This is the type of the foo, and so this is called the class of function. Okay, and after that we can call the foo. Just see that this is the foo, and also we can define another foo in here. Print other foo. And so this foo can be called right now. In the first place, the foo is seen, but in the other place, the other foo is seen. And so this is what? This is the override. That's it. We can write again the foo function in here. The overloading mechanism is different from the C++ or the Java. Okay, this is the override. We can override any function with another one with the what or at the downside of this code. Okay, because everything is an address, so the address can be defined with another one in here. But we need to expand our solutions in here. First of all, the x is 1 2 3, and so the print x can be given in here. See, this is the 1 2 3, and also we can assign what the Ali. Print x, and so if I rerun this code, the x is assigned to what? To the Ali. And after that, the foo can be built with what? With the foo, but just remember that the x has different addresses in here. Compared to previous one, because this is the constant, not a constant. This is string value. It is kept in the what? In the RAM with a different address. 1 2 3 is an int value, and so this possesses the different addresses. Okay, and so bar is equals to the foo, and foo can be called, and bar is also can be called in here, just like this one. Foo can be assigned in here because any address is assigned to the another one. Okay, so this is also override. Because we assign a different function name, but possess the different feature with the same idea. Okay, so in order to test these algorithms, so we need to create what another functions in here. For example, any function can be written as in a list. Therefore, each is a function and L and F. Okay, for x in L, F x. Okay, and also the print should be given in here. Okay, this is the L, and this is a list, and this is the function. We can pass the function name in here because it's just an address in this case, and so the foo x can be written in here just like this one. The print foo times format x, and end can be assigned with the empty space in here. And so for each function can be built with 1 2 3 4 5. This is a list, and also we can create the foo function in here just like this one. What is the output of this code right now? What is the output of this code? Okay, if I run this code, foo1, foo2, foo3, foo4, foo5 is called because we pass the for each to what? The list. And so the x is the list elements, integer values. But the f is possessed what? The function name. And so function operator calling mechanism is called in here, just like this one. And so this x is passed into the what? At each case to the foo. And this foo prints to this one. Okay? But with the same idea, 1, 2, 3, 4, 5, and so also we can give the print function. What is the output of the second code in here? What is the output of second code? Print is a built-in function. See, if I run this code, we have the what, the new line character in here, because it's the default arguments which is given in the print function is equals to the what, to the new line, not the empty space. Okay? And so any function can be used based on this information, so these properties. But just see that in the classes we have the different conditions, okay, for the classes. For example, if I run the class sample in here, def foo, the self mechanisms can be given in here, the print non-parameter foo. Okay, but also we can def foo self a, for example. We can write the parameterized foo. Okay, so this must be an override to another function. If I run this code, and then we will have no error in here just now. But if I create a sample just like this one, and so if I run this code, we have no error in here already. Okay, and s foo can be passed with a 10 in here, just like this one. So parameterized foo is called, but as foo is called right now, and so we will have error because the sample foo missing one required positional arguments a. What happened in this case? Can anyone tell me? Yes, foo is overridden in here. There are no two functions in here in this case. Only one function is contained in here in the classes. For the example of the 5, we can continue with the class sample again, and def foo self, and print foo function is called, and also def tar self print tar. Okay, or we can write the bar in here, and sample bar can be assigned with the tar. This is a complex case, and so as sample can be called in here just like this one. So if I run this code, and then we will have no error. Okay, and so, but what about if I call the foo function in here? What's the output of this code? Yes, it's foo. And so what about this one? If I call the bar, what's the output of this code? Which indentation? See, this is the bar, because the tar possesses the bar print, or we can write the tar. See, foo tar is called in here. What about this one? Sample x is assigned with the 100, and so we can print the sample x. What's the output of this code right now? What's the last part? Olmaz mı kıl? Beni niye beklemiyorsun oğlum? Yes, I'm waiting. Yara. Yes, 100. So, print sx. What is the output of this code right now? No, this contains also this one because the sample is the general class, right? And so s is also updated with the general x attributes. Okay, do you understand right now? Okay, and so we should continue with the MRO method 6 and class A. Just remember the previous lesson. Class B pass, class C B. Print MRO. What is the output of this code? Yara, because if the tar not possess the parameters of the self, and so we cannot assign the class function or the methods. If you don't write the self, and so we will get the error. Okay, that's it. This is syntax rule. Yara. Okay, and so Yara, let's continue with this one. What's the output of this code right now? A objects, but just see that first of all it's the R name, secondly B, thirdly A, and last of them is equals to what class objects. And you are correct, Yara. Thank you for your participation. Okay, but we need to continue with the another examples in here. First of all, we need to build our example class A, def self print a foo, okay, and after that class B, def self and print b foo, okay, and class C B pass. Okay, C drives and C foo. Which function is called right now? Yes, B foo. And so A. Which function is called at this case? Yes. Then B foo. Which function right now is called? Just tell me, Yara. B foo, yes. Because the B foo is already given here. Okay? So that's it. We need to take a break and we will start at 3 p.m. guys. Okay?